Hello everyone, Kotongwane the Nated God here. Today we'll be looking at question 2 of the Mechanotechnics N4 exam that was written on the 31st of March 2023. Right, now if you're interested in question 1, you can look at the answers I have for question 1 in conjunction with the questions or the sub-questions in question 1. Right, you can pause the video if you have to. Right, let's get right into question 2. Now question 2 reads as follows. Figure 1 shows a tapered ring gauge that is checked for accuracy by means of 2 precision bolts. 2.1. Use the dimensions given on the diagram and calculate the included angle of the ring gauge. Right, so we are looking for the included angle. Right, so as you can see, I've redrawn what's on figure 1. Right, I always advise students to redraw the figure that's been given to you as far as precision measuring. Right, it makes it easier to show all the labels as well as all the necessary diagrams you need to show on just one diagram. Right, now if you look here, you have 2 tapers. Right, you have this taper and then you have this taper as well. Right, so both tapers are such that they are also tangents. Why? Because they are only touching the precision bolts or the circles once. Right, so both tangents are also, both tapers are also tangents. Right, now what happens if you have 2 tangents meeting at a common point? The 2 tangents are said to be what? Congruent. Right, the 2 tangents, if they meet at a common point, are said to be what? Congruent. Now, like I said earlier, we have 2 tapers. Both tapers are what? Tangents. Now what I did here is I extended the lines of both tapers such that they meet at a common point, the common point being this one. Right, now you have 2 tangents, they meet at this common point, so both tangents are said to be what? Congruent. Now what condition of congruency does this fulfill? Right, now if you look here, once you've extended the 2 tapers such that they meet at a common point, we get this huge triangle. Right, we get this triangle. Right, now the condition of congruency that gets fulfilled here is one of side angle side. So you have this huge triangle, right, and the 2 sides of the triangle, which are the 2 tangents, fulfill the following condition called side angle side. So you have a side, you have this angle, then you have the other side. Right, so the sides being what? Being the 2 tangents. Right, now the side thereof is, the angle thereof is called what? Is called the included angle, which is what we're looking for. Now the included angle is denoted as I. Right, now when having this huge triangle, if we split the huge triangle into 2 right-angled triangles, right, the 2 right-angled triangles are exactly equal. Right, so meaning the 2 right-angled triangles are also said to be congruent. Right, and then if we name this angle theta, it means this angle is also theta. Right, again, both triangles are equal, right, or are congruent. Right, now if you have theta here, you have 90 as one angle. Let's call this maybe beta. Right, if that's beta, it means that's beta as well. Right, now if we were to draw a line, from the tangent, right, if we were to draw a line from the tangent going straight up, so if we draw a line going straight up such that it forms an angle of 90 degrees, right, if that's 90, this is 90 and that's beta, it means that this angle is what? Theta, right? So if you again choose to draw a line from the tangent going straight up such that it forms 90, right? Again, you have 90 degrees here, you have beta, meaning this angle will be what? Will be equal to theta. So what you then see here is that every time you draw a line from the tangent going straight up, the angle you get at the corner here is equal to what? Is equal to theta. Should remove these. Right. So that's one thing to note, right? Another thing to note is if we were to draw a line from the center of the roller, right? So we are looking at these green lines, right? If we were to draw a line from the center of the roller to the tangent, right, that line will be equal to what? Will be exactly equal to the radius of the circle, right? So the circle in this case is the precision ball, right? So if we were to draw a line from the center of the roller, of the precision ball, sorry, to the tangent, right, that line is exactly equal to what? To the radius, right? So this line is equal to the radius of the 30 millimeter precision ball, and then this line is equal to the radius of the 20 millimeter precision ball, right? Now going back to if we were to draw a line, or to what happens if we draw a line from the tangent, right, from the tangent line or the taper going straight up, right, the angle that gets created right at the corner here is equal to what? Is equal to theta. Now instead of going all the way up, we're just going to draw a line from the one radius to the other radius, right? Now if you draw a line from this radius, right, if you draw a line from the bottom radius to the radius at the top, right, what do you get? You get the orange, you inadvertently get the orange right angled triangle, right? But there's also another thing that you get. What else do you get? You get, okay, first let's label this thing. Let's first label this to make life easier for ourselves. Let's call it A, call it B, call it C, say that's D, call this E, call this F, right? And then since we have the orange triangle, let's call that G, call this H, call this I, right? So our sketch is fully labeled, right? Now another diagram that you get once you've drawn the line from the one radius going straight up, this is what we get. So what do we get? We get a parallelogram. We get this parallelogram. Right? We get this parallelogram, right? So the parallelogram CHFG or CFGH, right? We get that parallelogram. Now, why do you know about a parallelogram? The sides that are opposite are not just parallel, right? They are also what? They're also congruent. So the sides that are opposite are not just parallel, but they are congruent as well. Meaning what? Meaning CF being parallel and congruent to HG are equal. So CF is equal to HG, right? And then FG being parallel and congruent with CH, it means they are equal. So FG is equal to CH. right? Now, meaning, remember, in calculating for an angle, if you're looking for an angle, you either need two angles to get the angle in the triangle, or you need two sides, right? So we obviously don't have enough angles, so we're going to see if we can use sides to calculate our theta, right? We're going to use two sides to calculate our theta. Now, if you look at the orange triangle, right, we've already established that CF and HG are equal. So if we can get CF, you inadvertently get what? FG, right? And then once we have FG, if we can get HI, it means you will have attained two sides of a triangle. Hence, you can get your angle theta. Right, now, why is it important to get the angle theta? Now, our included angle, right? If this here is our included angle, it means that the included angle is equal to what? Theta plus theta, meaning our included angle is equal to 2 theta. So if we can get theta, right, to get the included angle, we just multiply it by 2, right? Remember, the question here is to calculate what? The included angle, right? So once we get our theta, we then will be able to get our included angle. Right. So first, let's calculate CF. Right. Now, CF is a part of which algebraic expression? CF is a part of the AF algebraic expression. What is AF equal to? So AF is equal to what? AF is equal to AE, so AE plus EF. What is this equal to? AE is equal to the 36,75, right? So 36,75 plus EF, which is equal to what? The radius of the 20mm precision ball, so 10. So what is AF equal to? AF is equal to 46,75 millimeters, right? Now, what is AF also equal to? AF is also equal to what? So AB plus BC plus CF, which is what you're looking for. So AF is also equal to AB plus BC plus CF, right? Now, AF we've already calculated, and it is equal to 46,75. So 46,75 is equal to AB, and AB is equal to the 4,25. So this is 4,25 plus BC, which is equal to the radius of the 30mm precision ball. So this is 15, right? Plus the CF, which is what we're looking for, right? Now 46,75 is equal to what? 4,25 plus 15 is equal to 19,25 plus CF. So to get CF, we simply transpose the 19,25. So 46,75 minus the 19,25. So CF is equal to what? 27,5 millimeters, right? So CF is equal to 27,5 millimeters. So if CF is equal to 27,5 millimeters, it means HG, sorry, is equal to the same. Remember, CF and HG are congruent, right? Hence they are equal. So meaning HG is equal to what? CF, which is equal to what? 27,5 millimeters, right? 27,5 millimeters, right? Now, HI, how do we get HI? Now, if you look here, FG is equal to what? CH. Now, what is FG? Remember, FG, we ascertained earlier that FG is equal to what? The radius of the 20 millimeter precision ball. So if FG is equal to the radius of the 20 millimeter ball, it means that CH is also equal to the radius of the 20 millimeter ball, right? So FG is equal to 10 millimeters, meaning CH is also equal to 10, right? And then CI, remember CI, earlier we ascertained that CI is equal to what? The radius of the 30 millimeter precision ball. So let's write this down. So CI, right? CI is equal to the radius, right, of the big precision ball, right? And then FG is equal to the radius of the small precision ball, right? FG is equal to what? FG is also equal to CH, right? Meaning CH is also equal to what? The radius of the small precision ball. Now, let's look at HI. HI is a part of which algebraic expression? CI is equal to what? CI is equal to CH plus HI, right? Now CI is equal to what? The radius. So this is R is equal to CH is equal to what? The small radius. So R plus HI, right? So to get HI will be equal to what? The radius of the big precision ball minus the radius of the small precision ball, which is equal to what? So the big precision ball has a 30 millimeter diameter, so this is 15 minus what? Minus 10. And what do you get here? This is 5 millimeters, right? So HI is equal to 5 millimeters, right? So HI is equal to 5 millimeters. Remember, HI is a part of the orange right angle triangle, right? So if you look here, we have HI and we also have HG. We have two sides. We're looking for theta, so we can get theta now, right? Right, remember what it is that we're looking for. Right? Remember what it is that we are looking for. Take that out. Right. So we have this triangle. Now if you look at this triangle, from this triangle we have HG and we have HI, so we can get theta. Now in this triangle, the HG is what? The hypotenuse. The side we are looking for is opposite the angle. So the trig ratio that we are going to use is what? Is sine. So sine theta is equal to what? The side opposite the angle, which is HI, over what? Over the hypotenuse. The hypotenuse is equal to what? HG. So sine theta is equal to what? HI is equal to 5 millimeters. HG is equal to 27,5, right? We are looking for theta, so to get theta you have to find the arcsine of 5 over 27 5, and theta will be equal to, so if you punch that in your calculators, you're going to get 10,476 degrees. Always round off to 3 decimal places unless it's been stated otherwise, right? So we have theta, but we are looking for the included angle, right? So the included angle is going to be equal to what? The included angle is equal to what? 2 theta, right? So 2 times 10,476, right? So if you punch that in your calculators, you're going to get 20,952 degrees, right? So there we go. You know, they wanted us to calculate the included angle, and there you go. As far as this problem, right, this is the approach I feel like each student, or this is the method I feel like resonates or can resonate with most students, right? Or this is the simplest way we can ascertain the angle theta, right? Now there's many other ways you could have done this, right? Whatever way that you feel comfortable with, that's fine, right? I'm comfortable with this one, and this is the method I'll be teaching you guys, right? Hopefully everyone understood the work we did today. On the next video, we'll be doing question 2.2. Right, sayonara.